With the modern slowdown of processor innovation, some companies are turning from traditional CISC, complex instruction set computing, to RISC, reduced instruction set computing. In this video, I will explain the reasons behind this and the advantages/disadvantages to each approach. Essentially, the difference between the two is that CISC has many specialized instructions which might need more than one clock cycle to complete. It represents a philosophy of solving problems on a hardware level, allowing for simpler software implementations. RISC, on the other hand, has fewer, more fundamental instructions, leading to simplified hardware but more complex software, as many more instructions are required to do the same thing as a single CISC instruction could. For example, to multiply numbers, a CISC CPU would use an add instruction, which loads the numbers, adds them together, and saves the result in one command. A RISC CPU would first load the two variables separately, then sum them together with a sum command or something equivalent, and finally save the results using store. Please note that the exact names of the instructions may vary depending on the instruction set. So what does all this really mean for the real-world application? Well, the flexibility of RISC and single-cycle instructions theoretically allows for more efficient software by cutting out unnecessary parts of the equivalent CISC instructions. RISC CPUs are also capable of much higher IPC, which is instructions per clock, due to the option of more widespread pipelining, which is only available when uniform execution cycles are guaranteed. In addition to that, RISC-based processors require less transistors to execute complex instructions, because they do not need to process these macro-like instructions of complex instruction sets, and can reallocate those unused transistors to boost computational performance. The previously mentioned instructions per task increase compared to CISC leads to higher memory capacity and bandwidth requirements in RISC. This is why RISC processors often have DRAM chips integrated into the package. Currently, the main instruction sets for the respective approaches are x86 for CISC and the ARM instruction set for RISC. The original x86 instruction set was released in 1978 and featured 82 instructions. It now includes 1,503. This further complicates the implementation of fully featured CISC designs and uses up large chunks of the given transistor budget. The ARM instruction set was released in 1985 and, depending on its implementation, features around 50 instructions. That means that it has roughly 97% less instructions. So, in conclusion, not only is RISC starting to become more and more of an attractive option from a performance perspective, it's also the only option for many chip designers, as the x86 license is only held by 4 companies. So, being faced with the slow decline of Moore's Law and the complacency of these x86 chip designers, the higher programming effort seems like a worthwhile trade-off for significant performance and efficiency increase. However, there will definitely be a long transitional period where both software and hardware will slowly mature, and during that time, there may only be limited support for RISC devices. As a result of that, there may not be a lot of consumer-oriented devices featuring RISC processors for an extended period. The transition will require large investments that will take a long time to actually be profitable. As for the current state of things, ARM is already licensing to giant companies such as Apple, who have adapted their designs into the M1 processor, after being disappointed by the merely incremental performance gain Intel was achieving. So, the slow transition to RISC-based devices has already begun, especially Apple has proven to have an incredible ability to force radical change in the industry. See Thunderbolt lithium-ion batteries for laptops, and even biometric security. Arguably, the main reason CISC has had its dominant position for this long is that Intel simply beat ARM to the punch. They were first, and therefore got the wide adoption, especially through the IBM S2, which featured the Intel 8086 chip. I personally believe that RISC will define the future, and I hope that widespread adoption comes sooner rather than later.